Hello everyone. Today we are going to learn about multiplexer. What is a multiplexer? Multiplexer is a combinational circuit that accepts 2 power n inputs and directs any one of these inputs to the output based on the status of select lines. Let us see how it is. We are considering 8x1 multiplexer, and multiplexer is one based on the select lines. It directs any one of the inputs to the output. Now it is a 8x1 multiplexer. We know it is like many to 1. There are 8 inputs, that means 2 power 3 inputs are there, 2 power n input lines, and it requires n number of select lines. Therefore 3 is there, 2 power 3 8, therefore 3 select lines are required here, n equal to 3. So out of 8 inputs, one input will be connected to the output based on the status of select lines. This is a multiplexer. It is also called as many to 1. We can have 4 to 1, 2 to 1, 16 to 1, like that. Different multiplexers. Now, if you see the truth table of this multiplexer, select lines S2, S1, S0, output Y. Depending on the select line's status, particular input will be connected to the output. So if S2, S1, S0, all three are 0, 0, 0, then I0 is connected to the output. If it is 0, 0, 1, I1 is connected, like that, and so on. If S2, S1, S0 are 1, 1, 1, I7 will be selected. This is the definition of a multiplexer. A digital IC is available in the market. The IC 74151. So many ICs are available, and here we are considering the IC 74151, which is a digital IC and which is a multiplexer IC, and it is a 8-to-1 multiplexer. Now let us see the pin diagram and truth table of this IC 74151. Because our subject is the digital IC design, first we will see what is the digital IC that is available and how we can eliminate the hardware requirement in VHDL programming we are going to see. Now this is the pin description of the IC 74151. If you see this, all the input lines are logical input lines, are input data lines, and enable signal for the IC. Then we have output Y, and a complemented version. That means active high output and also active low outputs are provided by the manufacturers, and the select lines S2, S1, S0. Okay, this is the pin diagram. Let us see briefly about each one of these pins. So this is the 8th pin, which is a ground pin, and it has 16th pin is VCC pin. This IC is a 16-pin IC, and all the manufacturer's details will be available in the manufacturer's data sheet. Now coming to these select lines, 9, 10 and 11 are the select lines S2, S1, S0. So this IC has 3 select lines at pin numbers 9, 10 and 11. And inputs are from I0 to I7, but the pin diagram, if you observe, pins 1, 2, 3, 4 are from I3, I2, I1, I0, and pins 12, 13, 14, 15 are at I7, I6, I5, I4. So from I0 to I7, these are the various pins. Then enable pin is pin number 7. Like that, this is a digital IC available in the market, and pins VCC and ground, these are called power supply pins of the IC. Coming to the enable pin, it is active low enable signal, Therefore, when enable equal to 0, this IC will respond to the inputs and it will provide output based on the status of select lines. But when enable equal to 1, this IC will not respond to the inputs and the output will be always 0. That is what about enable pin. And now coming to the input pins, that means data pins, data inputs, pin number, I7 to I0. Inputs I7 to I0, 8 pins are required. There are 8 data inputs to the multiplexer. Then coming to select signal, 3 pins are required for select signals, that is S2, S1, S0, and they are the select inputs to the multiplexer. And if you see Y and Y bar, these are the 2 pins. Y is active high output of the multiplexer, while Y bar is active low output of the multiplexer. Now if you see the truth table, when enable equal to 1, just now we have mentioned that irrespective of the select lines, output will remain 0 because enable signal is active low signal for this IC. Therefore, when enable equal to 1, when select lines are irrespective of the status of the select lines, output will be 0 and Y bar will be not of Y, that is 1. When enable is 0, depending on the status of the select lines, the output will be assigned, or the output we will get as I0, I1, I2, I3 like this. So depending on the status of the select lines, one of the input will be connected to the output or directed to the output. When Y equal to Y0, that means when S2, S1, S0, 0, 0, 0, Y is I0 and Y bar is I0 bar. Similarly, 0, 0, 1, Y is I1, Y bar is I1 bar. Like that, when enable signal is 0, select signals are 1, 1, 1, then output is I7, Y is I7 and Y bar is I7 bar. Like this, we can design, we can understand the truth table of the IC 74151. IC 74151 is a 8-bit, IC 74151 is 8x1 multiplexer. And if you want to design a 16x1 multiplexer, you need 2 ICs, 2 74151 ICs. That means each IC is an 8x1 multiplexer. Therefore, if you want to design a 16x1 multiplexer, you need 2 ICs. That means the hardware required is doubled. So this is what about digital IC, which is available as multiplexer. That is nothing but 74151 IC. Now let us see the VHDL code for a multiplexer. Now we are going to see VHDL code for an 8x1 multiplexer. Okay. Now for any VHDL program, we have to give library declaration followed by entity declaration followed by architecture body. So library IEEE and use IEEE dot standard logic 1164.all. Then entity, name of the entity is, here I have taken the name as MUX 8x1 because you can also write VHDL code for 16x1 MUX or 4x1, 2x1, whatever you want. So entity MUX 8x1 is port. I is we have 8 inputs. Therefore, I is the input port, which is a standard logic vector. And the size of this array is 7 down to 0. And yes, select lines we take. So yes, it is also a input port. We have 3 inputs here. Therefore, standard logic vector 2 down to 0. and Y bar are the output ports, and they are single bit port, therefore standard logic. And name of the entity, that is mux 8 by 1. This is the way we declare entity for this multiplexer. And now coming to the architecture body, we are going to write in behavioral model because we have truth table, and therefore architecture multiplexer mux 8 by 1 in behavioral mode. Therefore I have given this name, that means entity name followed by the style of modeling. So mux 8 by 1 behavioral of entity name, that is mux 8 by 1, is begin process. Here I would like to mention only the select lines because whenever there is a change in select lines, then only there will be change in the output. So always process statement is followed by a sensitivity list. Therefore process, then sensitivity list, and here we have only select lines because even if there is any change in the input lines, there will not be any change in the output. Only when there is change in select lines, there will be change in the output. Therefore process followed by sensitivity list, that is only select, and then begin case S is when 0 0 0, that means S2 S1 S0, when they are all 0 0 0, then y output y is assigned with I naught and y bar is not of y. And when S is select lines are 0 0 1, then y is I1 and y bar is not of y. When select lines S is when 0 1 0, output y is I2 and y bar is not of y. Similarly, we can from the truth table we can complete all the statements. That means when 0 1 1, output is I3 and y bar is not of y. Similarly, when 1 0 0, output is I4 and y bar is not of y. When select lines are 1 0 1, output y is I5 and y bar is not of y. When select lines are 1 1 0, output y is I6 and y bar is not of y. When select lines are 1 1 1, output y is I7, y bar is not of y. So we have covered all the conditions, all the possibilities of select lines, and then when others, output y is equal to 0, y bar is not of y, and like this we can use end case statement here, end case, end process, end the architecture, that is the name of the architecture. So in this way we can write a VHDL program for 8 to 1 multiplexer. 8 by 1 multiplexer or 8 to 1 multiplexer or 8 is to 1 multiplexer. Similarly, you can also write a VHDL program for 16 by 1 multiplexer just by changing the size of the array of the inputs and select lines. That's all. So how do we write VHDL program for 16 by 1 multiplexer? Just here, if you mention the size of the vector, if you change the vector size, that is sufficient. Now for a 16 by 1 multiplexer, you just write I is a input port with the standard logic vector 15 down to 0, and because 16 inputs are there, right, and 2 power 4 input lines, so n is 4 here, so 4 select lines are required, so s is in standard logic vector 3 down to 0. So with these small modifications you can also write Of course, Y is a single bit. So with these small modifications, you can write a VHDL program for any size multiplexer. So this is what about the multiplexer, and hope you have followed this lecture. And in this lecture, we have learned how to write a VHDL code for 8x1 multiplexer, and we also have learned about digital IC. We also have learned about digital IC, which is IC 74151, and its pin description and its truth table. Right? Hope you have followed my lecture, and thank you for your patient listening. And if you understand, you please like it and share it to your friends, and express your doubts in comments session. And you also subscribe my channel for further lectures regarding your digital IC design subject. Thank you. May God bless you.